Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome in this lecture of Module 1 on Advances in Engineering Geology. In previous lectures, we have discussed about the introductory aspect of engineering geology. Now in these lectures, we will study about different constituents of geomaterial, needs of categorization, parameter used for classification, and classification of engineering geological ground. In these lectures, we are going to cover about the geological ground concept and categorization. In these lectures, we are going to highlight about the geomaterial constituents of geological ground, why we require to categorize, and what are the parameters we are going to utilize for categorization of ground, and then finally about the classification of engineering geological ground. Friends, as you know, the surface and subsurface part of crust or earth are comprised of igneous, metamorphic and sedimentary rock. In igneous rocks, we have acidic rock, we have basic rock, we have ultramafic rock. In sedimentary rocks, we have clastic rock, non-clastic rock and varieties of metamorphic rock. Besides these, we have derived part or derived material as weathered material or fragmented material as a deteriorated material and waste generated by industrial and domestic activities of human. Therefore, we have varieties of natural as well as anthropogenic induced material. In natural, as we have already discussed, sedimentary rocks, metamorphic rocks, and derived material as in form of soil and others, and then waste dump, and about some modifications, etc. So therefore we can say that we have varieties of igneous rock. If we are trying to categorize igneous rocks, then we can say that extrusive rock, intrusive rock, and in between these two, hypabasal. Extrusive rock is able to reach on the surface, and we have number of example of volcanic rocks. In case of the intrusive rocks, we have varieties of rocks located within the earth crust and may come due to other secondary geological processes. If we are going to see igneous rock in view of composition, we can say that it can be divided into basic, acid, mafic and ultramafic on the basis of presence of silica. On the basis of composition and on the basis of the location of this igneous rocks, we can see varieties of rocks belonging to different igneous group on the basis of position and on the basis of composition. Here we can see a view of the acidic rock, mafic rock, ultramafic rock, some volcanic rock like basalt, some amygdaloidal basalt and some massive basalts. Beside this we have rhyolite and other rocks. In sedimentary rocks, we can see broadly in two categories. One is a clastic and another is a non-clastic. Clastic is mainly due to mechanical action of different geological agencies like water, like wind, like glacier, etc. And non-clastic is mainly chemical origin due to chemical precipitation, and we have example of limestone, or biochemical also biogenic limestone, some phosphate, some sulfates, etc. So in clastic rocks we have sandstone, clay stone, siltstone, shale. In non-clastic rocks we have carbonates mainly, dolomite, limestone, phosphorite, sulfides and others. If we are going to see this natural sedimentary and metamorphic and igneous rocks, we have varieties of rocks. We have huge numbers of rocks required to describe by different names. Therefore, it is important to derive any tools so that this type of distribution of huge number of rocks, varieties of derived material, human generated materials, etc. can be grouped in certain category so that the other member of team can understand in easy way and with confidence. Therefore, we require to group these type of material in certain categories. For categorization, we have selected very simple 4 parameters. One is about the constituents, another is about the response or property, another about the distribution in which area we are going to see such type of ground, and qualitative description about the preparation and treatment levels. So in view of these 4 parameters, we are going to categorize different type of grounds in these categories, like crystalline ground, like massive ground, like bedded ground, like banded ground, like layered ground, like weathered ground, like vesicular ground, like pothole ground, like piezoelectric ground, like conglomeratic ground, like foliation ground, fractured ground, jointed ground, solution cavity ground, waste ground, soft ground, and glaciated ground. The ground can may be increased more, or there may be more ground, but for our minimum requirements, we are anyhow able to divide the whole type of region in this type of ground, so that a semi-skilled person or the persons belonging to other engineering disciplines can be able to understand for their practical use. As far as crystalline ground is concerned, we are going to consider all type of area which is made up of crystalline rock. For example, made up of igneous rock, particularly plutonic rocks, made up of sedimentary rock like quartz-granite, made up of metamorphic rock like quartzite, like gneiss, etc. So all the materials, if belonging to crystalline group, then we are going to consider this type of ground as a crystalline ground. This type of ground is mainly distributed in case of the area covered by plutonic igneous rock, covered by the sedimentary rock rich in quartz and showing arenite type of arrangement, then metamorphic rock rich in quartz and rich in some silica dominating materials. This type of ground is intact, hard and compact in nature and not showing any type of interface or discontinuities, and considered as a good quality of ground for development of any engineering project, particularly related to civil engineering or mining engineering, etc. Level of preparation and treatment, simply we are going to introduce here qualitatively as level. So higher level, lower level or moderate level. So in this type of grounds, we are going to see high level of preparation but very low level of treatment. Only we require to consider the treatment of the fractures present. Here we can see a photograph representing crystalline ground. Massive ground is close to crystalline ground, but this type of ground is not going to show any crystalline features. In other property, this massive ground is the same as we have already discussed in case of the crystalline ground. Similar to the crystalline ground, this also shows requirement of preparation related to high level, but the treatment almost zero level or very low level of treatment. The next type of ground is a banded ground and bedded ground. So first we are going to discuss about the bedded ground. Bedded ground is a ground which is comprised of beds of sedimentary rocks of same or variable thickness, variation in composition or same composition, continuity and change in orientation or same orientation, traversed by bedding surface or not traversed by bedding surface, etc. This type of ground can be observed in case of the older Precambrian and Proterozoic sedimentary rocks, and the basins belongs to these type of sedimentary rocks. In India, we can see the central part and southern part of the area, particularly sedimentary basins like Vindhyan Basin, like Kudafa Basin, etc. Number of basins. So that area we are going to cover under bedded ground. As far as property is concerned, because there is a variation in thickness, variation in continuity, variation in lithology, variation in orientation, therefore the strength and hardness as well as durability depends on continuity, thickness, nature of strata and orientation of bed. This ground may be divided as homogeneous if the all features are same, and it may be made up of thick bed, association of thick bed or thin bed association or alternation of thin and thick or compositional alternation like sandstone shell, etc. And orientations may be perpendicular, parallel or inclined with respect to our interest. Here we can see this is the continuous thick rock, this is the non-continuous thick rock, this is the thin, this is the alternative thick and thin. We can see here the number of interfaces here running perpendicular to the applied direction, here applied direction or applied load direction, or we are going to put in form of the building or in form of dam or in form of any engineering structures. So there is a variation in mechanical response of this type of bedded ground. Therefore, we require variable level of preparation and treatment depending on the association in view of the thickness, in view of the continuity, in view of the orientation with respect to the applied load or applied interest. Layered ground similar to the bedded ground, but the layered ground is not so linear or planar in nature. It is irregular in nature. And we can observe this type of ground in case of the basaltic flow. This type of ground or rhyolitic flow, this type of ground is distributed particularly in area where we are going to encounter the flow type of volcanic rocks or schist type of metamorphic rock, etc. The property and response, particularly related to strength, related to hardness, related to durability, etc., depends on the orientation, continuity, homogeneities, etc. Therefore, we can say that here we can see here the different flow due to the volcanic rock flow, particularly basalt or particularly rhyolite and others. Here we have different type of pockets related to red balls or green balls. The pockets are going to respond differently in comparison to the intact portion. Therefore, the strength and durability as well as hardness varying with respect to the nature of foliation. Either in case of area dominated by schist, either in case of area dominated by the basaltic material. So level of preparation and treatments also depends on the orientation, continuity, thickness and nature of the flow. This type of ground we can see in central India and other Deccan Trap area and other and different parts of the world also. Here you can see the view of this red balls and others. Next type of banded ground which is close to the bedded ground. Only here change in compositional attributes. Therefore, the color wise each bands are looking differently. We can see good example as a banded hematite quartzite or banded hematite jasper or in case of porcelainite. And this type of ground is mainly associated with the iron ore associated area or porcelainite associated area. And in India we have rich this type of ground belonging to the iron ore series distributed in Jharkhand, distributed in Odisha, Madhya Pradesh, etc. The ground is imparted high hardness and strength and moderate durability. Therefore, the level of preparation and treatment require moderate to high level of preparation based on the nature of bed and the low treatment due to good quality response of this ground with respect to the external engineering development. Weathered ground is a very notorious type of ground due to variation in size, shape and extension of material derived due to impact of our surroundings. This type of ground is localized in nature and can be observed in any parts of the country or in any parts of the world. And property wise, there is a continuous change in strength and hardness and durability with respect to extension from lower to upper or upper to lower. Therefore, high level of preparation and treatments are recommended for this type of ground. We can see here the lower side is intact in nature and made up of intact rocks. When we are going to move upside, then there is a continuous reduction in the constituent size and finally at the top we are going to get finer material and some part is dominated by some rock fragments and others. If we see here from the lower side to the upper side, then we can say that this type of variation in constituents attributes is responsible for variation in strength and hardness as well as durability. This type of ground requires very careful observations, monitoring regarding the preparation and treatments. Here we can see here one photographs. This photographs is related to the Vindhyan area, particularly upper Vindhyan area. Here the rock exposure is going to show some weather defect in this downside. Vesicular ground is a peculiar type of ground due to presence of vesicles of filled, saturated, partially saturated, unsaturated, filled by loose material, filled by secondary materials. This type of ground generally associated with the volcanic rocks, particularly rhyolitic and basaltic. Due to release of gases, there is a formation of number of cavities of different shapes, different extensions and others. Therefore, this type of ground is characterized by variations in hardness and strength depending on frequency of vesicles, shapes and conditions of vesicles. Therefore, it requires moderate level of preparation and high level of treatment based on frequency and nature of the vesicles. We can see here one view. This nature, this vesicles, if we are going to see this type of vesicles, these vesicles are open on the surface but taper at the lower end. Sometimes these vesicles we are going to see is a field informed by the loose material, and sometimes it is a field by secondary precipitation. This part in geology we are recognizing if these vesicles are filled by the by secondary minerals, then we are going to recognize as amygdaloidal type. But we are here for our engineering purpose, we are going to consider these as a vesicular ground. It is a field by secondary material or loose weathered material. It is saturated, fully, partially or dry in nature. So all the conditions going to affect the level of preparation and treatment. Potholes ground similar to this vesicular ground due to release of gases. The pothole ground is a form due to action of water or due to subsidence. This type of grounds we are going to encounter particularly in river bed. Number of river bed where when we are going to construct some dam and others, when we are going to channelize river, then we can see the river beds dominated by such type of pots. As there is a presence of number of opening of saturated, filled, unfilled, partially saturated, fully saturated, etc. Therefore, this type of ground is going to show different type of preparation and different type of treatment because its strength is varying. The intact portion is showing different strength, but this corner portion is showing different strength and this opening is showing different strength. So there is a distribution of strength, heterogeneity. Therefore, this type of ground require high level of preparation. Another type of ground we can say that piezoelectric type of ground, and this type of ground we are going to encounter particularly in area where we are going to see about the bauxite and laterite. Some mooring also. This type of ground is showing differential hardness and strength depending on frequency, size, shape, constituents of the piezoelites. Therefore, in this case, we require moderate level of preparation and treatment. Agglomeratic ground is in behavior wise it is similar to the piezolytic ground. However, the piezolytes are smaller in nature, but in conglomerate we are having fragments of the bigger size, gravel size, boulder size, and etc. And there is a variation in size, shape. In these conglomeratic grounds, we are going to consider rounded fragments as well as angular fragments also. This type of grounds we generally encounter in case of the faulted zone or in case of the zone where the erosion is going to dominate and form an unconformity. When the strata is exposed to atmosphere for certain gap of time, then in such situations we are going to get such type of ground. This type of ground, as we know, constituents by it is heterogeneous in nature. Therefore, we expect variable hardness and strength depending on the frequency, size, shape of the fragments. As far as the level of preparation and treatment is concerned, it requires high level of preparation and considerably level of high treatment as per the nature of this ground in view of the frequency attributes of the rock fragments. Here we can see this type of ground having some finer material here and some coarser rock fragments. So coarser rock fragments, when we are going to utilize, apply some force or applied some load, then the behavior of this coarser component is different and the finer component is different. Therefore, it is a heterogeneous in nature, particularly in strength response. So require high level of preparation and treatment to ensure a good ground. Next type is a foliated ground, and generally we encounter in case of deformed and tectonic zones where rocks are folded are foliated in nature. You can see the number of foliations and others. In view of the response of this zone is different and the response of this zone is different, response of this zone is different. Therefore, there is a variation in hardness, strength and durability of such rock requires moderate level of preparation, no problem, but high level of treatment due to heterogeneity in response of this strata. Here, this view you can see this is also taken from the deformed part of the Vindhyans, particularly in Kajarhat area. Fractured ground, friends, as you know, the fractured ground, as the name indicates, any rock strata or material traversed by fractures of undefined pattern. If it is defined, then jointed. So fractured rock is weak in nature and showing variable hardness and strength depending on frequency, extension and depth of the fractures. Therefore, the preparation requires moderate level, but it requires high level of treatments. Next type of grounds we have jointed ground, that is also known as engineered ground. We are going to give more stress on this type of joint ground or jointed ground in our future classes when we are going to elaborate the mechanical response. As far as constituents is concerned, this ground is made up of rocks and joints. This type of ground is generally associated with deformed and tectonic zones. As this ground is traversed by a number of joints or interfaces, and as you know, the simple presence of a crack or fracture is going to damage the whole building. So you imagine this number of interfaces is going to change the status, and similar to the fracture ground, this ground also requires moderate level of preparation and high level of treatment. This is also view from the Dhanrol quartzite or the Dhanrol quartz granite. Here we are going to see this type of the ground, bedded ground, and some transverse ground also from the Vindhyans, from the Sonbhadra area. Solution cavity ground is a very peculiar type of ground and creating lot of complications in assessment of strength or hardness or durability, because the dimension of this solution cavity is going to enhance with respect to time depending on availability of acidic water and the suitable surrounding conditions. So when we are going to treat this, and if we are going to not consider about the time component, then after treatments these cavities may be enhanced in size and shape or change in shape and going to create a lot of problems. This type of ground we generally encounter in case of the carbonate dominated area. Next type of soft ground, and that is a very interesting ground. And the soft ground we are going to consider the ground made up of sand or made up of soil. This ground is a purely comprised of derived material due to weathering or due to transportation, erosion and others, abrasions and others. And we have here, we can see here, the good exposure of the soily soft ground from Ladakh area. This type of ground required high level of preparation and treatment depending on the nature of structures which we are going to construct. Glaciaceous ground is a very peculiar type of ground we generally encounter in case of high altitude area or the area of cold region where there is a variation in temperature less than 0. Here we can see that the rock strata or debris material is bounded by some snow and ice. So behavior, mechanical response or strength and hardness of this glacier or snow part is different and rock part is different and derived material is different. Therefore, this type of ground is a very peculiar. As you know, the stability of this type of ice or snow mainly depends on the temperature. Therefore, this ground is a temperature dependent ground. And it is very complicated in nature when we are going to analyze such type of ground to solve the avalanche problem and others, or stability concerned to the techniques related to cold region. So this type of ground is still a challenge to us to solving different type of problem concerned to stability of the natural slope or foundation or creation of underground structures and varieties of ground control problem. Here we can see this photographs representing this area and located nearby the Shatopant Glacier and Badrinath area. Next type of ground is a waste ground, mainly dominated by human activity like mining, like the release of fly ash, release of the waste from the industry or domestic and others. As the size of this material, you can see the size here change, the size here change, the size here change. So some of the big blocks and some of the smaller pieces, some of the finer dust type of material. So we can say that this type of ground is comprised of varieties of materials showing wide range of size and shapes. Therefore, the hardness and strength response of such type of ground is very uncertain and requires high level of preparation and treatment. So this type of materials I have prepared myself based on experience and other taken from some material from our own work and some from the some engineering geological books like written by Bell and Kashalu and the other sources also related to the website, etc. Friends, now we are going to conclude. The various kinds of grounds are a preliminary attempt to categorize for engineering geological application. The initial assessment of preparation and treatment may be helpful in planning and design of engineering structure. This categorization of different types of ground is relevant in proper planning and design, and it is actually an approach from the qualitative geological information toward the quantitative direction. Dear friends, in this class we have discussed about different type of grounds, and this is an initiation to approach an area for engineering geological application to translate qualitative geological information for partially or semi-quantitative direction. Thank you.